So today we're going to talk about how to secure a massive scale of applications. But before I'm getting into the topic and into the details, I want to have a quick introduction about myself. Usually people say that I'm doing quite long introduction about myself, and I like to speak a lot about that. So this time I'm just going to do it quietly. I'm not going to speak at all. I hope it's going to work. Yeah, that sucks. Hope that pretty much summarizes who I am. So let me explain you why this talk is important to you. So when I'm trying to get to the root of a problem, I'm asking the question 5 times. I'm asking why. And maybe we'll get to the root of the reason why this talk matters. So also it's going to be pretty quiet. I hope it's good enough reason for you. All right, so the agenda is pretty vague. This is what we're going to do today. We're going to talk about what you always being told to do, what is the best practice, and how not applicable is that when you're trying to scale up your applications. Or in fact, we're going to talk about all of the hurdles you may have when you're trying to scale the application security for your company or companies that you're consulting to. So let's start with the introduction, the characteristics of what we do and the main challenges that we're facing with. Most of them, at least in the first thing, are not focused on technology at all. First thing is that we work with people, and we need to get all the right buy-ins to start our program, or even start talking about application security. So assume that's me. It's the pretty version of me, and I am tasked to do application security for above 100 applications within NCR. In fact, this is the software R&D of the company. And we have several types of applications. We have SaaS applications. We have on-prem applications. The technologies are very different. And sometimes we may have combined applications, both web, both native, and it's quite a challenge to do security for all of them at once. Although there are things that we can do, as we will discuss in this meeting. And beyond that, when I've been tasked to do that, I've been told by our executive leadership, you know what, Nir? You have one thing to do right. Keep us off the news. It's a really strong statement, because when someone tells you keep me off the news, it means he's willing to invest money in it, which is true. But yet the challenge, even with unlimited investment, is way bigger than just stating keep me off the news. So let's talk about the parties that you need to work with when you try to do application security. So sometimes I hear, just do application security, speak with the engineering team, speak with the product teams. No, it's not like that. It doesn't work like that. You always need to coordinate with the right parties in the company. So for instance, in the legal matters, sometimes we are committed to customers to do penetration testing, and they know about that. Sometimes I don't know about that, sometimes engineering don't know about it. So we need to grab this information from legal. And IT operate the systems, and CISO have a portfolio, and you don't want to be apart from this portfolio. You want to be part of the overall information security plan. And then, I don't know, how many of you heard about NCR? Please raise your hand if you heard about NCR, except my team there. Okay, so NCR is that's the National Cash Register Company, and we have ATMs, point of sales, fuel pump software that we sell, and we definitely have hardware that we sell. So sometimes if you want to do a penetration test, let's say for an ATM or a self-checkout device, we need to coordinate it with the hardware teams. With regards to product management and solution management, you need to make sure that you actually, everything that you find will go into the roadmap. Not every finding in security is a bug that can be fixed by engineering. Sometimes you have bigger architectural problems and you need to put that into the roadmap. So you need to get them as well. Sometimes you have professional services, and again, it's applicable for NCR, but you can definitely expand it to however it works for you. Professional services may be the team that actually implements your product, maybe develops extensions for your product, or the guys that eventually go and deploy the product for customers if it's an on-prem installation. In that case, you need to make sure that you can work with them because you provide your security guidelines and they should follow that. And lastly, internal audit, which are the guys that eventually take a look at the most critical assets in the company and they audit them. And trust me, you want to follow the guidelines. So when we're talking about all of this variety, this is all right for a particular product. But then you need to look at 100 products, and that becomes challenging because you want to map the people or the organizations that you need to work per product. For instance, there are products that maybe you may need to take a hardware with you, or get into hardware. Sometimes you don't need that. Sometimes it's not that regulated or even observed by internal audit. So you need to know who to work with. And 100 applications, I'd say it's not that easy to get into this situation that you actually have a mapping of all of the parties that you need to work with. So then you think to yourself, okay, I'm going to do this mapping. That's how it's going to end up eventually. And there are ways to do that. So at least the way that I approached it is by speaking with all of the engineering VPs and actually getting a prioritized list of all of their products. This is one case study, but it really varies between companies and what you need to do. So that was like the human factor thing that we had to pass. So I think that when you do application security, you actually need to scope what you're going to do security to. Meaning, application security and IT security may have some overlap, but it's not the same thing. And when we do application security, we need to say, this is what I can do. This is, like in security, we like to call it whitelist, but this is pretty much a whitelist. Hey, this is my scope. If there's something beyond that, I don't know about that, so you should educate me about the additional stuff that is going on around that. So the first example is actually taking a look at the product offering. If you have a product that is installed on-prem, it can be an enterprise product. In enterprise product, I'll give you an example from the point of sale world, but you can rely it to anything else that you have. So in point of sales, let's say that you need to calculate a tax, and the tax is different per state. Sometimes you need to put different numbers, sometimes you need to do more calculations, and therefore you may have an extensibility mechanism. So the core product may not have the tax calculation function, but you may have to extend it. And when you extend it, you may need to secure that as well. Many times, you can actually, well, not you as security people, but engineering people just avoid that because it's just an extension on top of a current platform, which is not true. By the way, it's not only for enterprise products. If you look at Burp, for instance, which is a proxy, you can write extensions to Burp. Who makes sure that Burp with its extensions is actually secure. Just think about this functionality. So it can apply to end user applications as well. On the other hand, on a platform as a service scenario, people may actually write services that will run on your platform. And if they can do that, so engineering team can do everything right, they can say, I'm following all of the guidelines. It can be the best practices that are not related to security. It can be all of the security guidelines that we also put through. But then someone else comes, it can be a partner, it can be professional services, and they do BY, bring your own API, BYO API, which also adds some challenges on how do you do application security if someone wants to develop a service on top of your services. Well, actually, it's more like a side service that works with your services. How many of you heard about the best practice to develop a central library, a central security library? Raise your hand if you heard about this best practice. Okay. That sucks. Gotta tell you. Having a central security library may be very good for a company that have only few products, a handful of products. But having a library that actually is applicable for all types of products, that's really hard. You may have Spring Security for Java, you may have Hibernate for ORM as database access, you may have inversion of control in your products, and you cannot have one library to control all types of those products. In addition to that, sometimes you have native products, sometimes you have SaaS products. Input validation isn't the same on both sides. And in addition to that, if you're actually developing a central library, it means that you're trying to be more mature than you are today. Which means that you should probably already have some sort of static code analysis. If you have static code analysis, leverage that. Try to use that to find the flaws that you're looking for. By the way, part of you may disagree with me. I'm just sharing my personal experience with regards to technologies and how it works. So, with all of those challenges, we also need to understand that eventually, we are security people. And as security people, we know our domain. We know how to explore technologies, we know how to explore processes. But how can we really understand everything that engineering do? You have a bunch of databases. You have CI/CD tools, other automation tools, configuration tools. How can you understand in all of those technologies? That's nearly impossible. You can understand the concept, you can understand how to integrate with those, but you cannot understand all of those. But yet, I don't think it's a big challenge. Understand the baseline, understand where you want to integrate yourself, and we'll talk about it later, and let the names just float. But not only the non-security tools are varied. If we look only at the narrow application security realm, we will see that we also have a bunch of domains here. So if you look at, I'm just having like 4 examples, but you can definitely take a look at other examples. So the first example is just having something called static code analysis. It scans your code statically for vulnerabilities, and if it finds something according to specific rules, they usually have their best practices, then it should notify you about that. The decision about what to do with this is later, but at least it should notify you about the vulnerabilities that you have. And then you may have dynamic application security testing tools, which is some sort of a scanner. That's all I can say. But then you can actually take that even one step further and do interactive application security testing, which is let's say the son of the DAST, which essentially has an agent on the server side or an inspector on the server side that actually checks the memory on the server, and while you do your testing, it actually knows if you have a security vulnerability or not. If you've never heard about this technology, I warmly recommend you to take a look at this category. Very interesting, very sexy. And last thing is software composition analysis. One of the things that is pretty common is third-party library vulnerabilities, and you want to identify those third-party vulnerabilities. It's good from the security perspective, but on the other hand, you can sell it to the company, to the different stakeholders as a legal tool as well. Meaning, if there is a third-party library that has a GPL license, you can say, okay, that's not me, that's a legal thing. You can just figure this without. And obviously there are other domains, you can explore the other domains. I'm just saying there are so many things to do in application security, although it sounds like a narrow domain. And yet, we are expected to understand all of them. Maybe not be the expert, but at least understand what each one does and where to integrate each one of them. And except all of those tools, the R&D tools and the security tools, how many people can actually know that, know what to do? So here we have an engineering organization of 100 people. You can try to count it, you won't have enough time. And there are some statistics about what is the size of an application security team of the whole R&D organization. So I took a look at the research that BSIM did, and I saw some information from Google. And actually, you can have between 1% and 2% of application security labor out of the whole R&D organization. You know, in IT security, we're talking about 6, 8, 9% of investment of the whole IT investment. And in application security, we're looking at much lower numbers. But yet it's only labor. It's not including tools. So this is one of the reasons why we have this talk today. How do you scale up security when you don't have enough labor? And obviously, you know, I can come to our executive leadership and I can say, hey, you know, I need more than that. They will tell me, take a look at the statistics, and basically that's what you have. So the way that we track that and the way that we scale it up is by following several guidelines that we interpret them in our way. How many of you heard about an application security maturity program? Okay, so let me give you some background about that. An application security maturity program tracks the process that you have within the product that actually follows security. And there are several standards that you can follow. The top standards are OpenSAM by OWASP or BSIM. And you can actually compare yourself to other companies and see what they do. Because eventually you want to go back to your leadership and say, hey, you know, this is where we are compared to other companies. So the one that I'm going to present you is the OpenSAM application security maturity standard. I'm not going to present exactly all details. I'm just going to show you what is the best practice versus how difficult it is to do that. So the first domain is governance. And the guy that you see on your left, this is a consultant. And he says this is the best practice, which is the reason why we have this talk. This is the reason why I submitted the CFP. So the best practice is to have a secure software development lifecycle. Yes. Checkbox. Yes, we have secure development lifecycle. No. In fact, implementing a secure development lifecycle, even for one product, It's difficult because you need to integrate in all of the parts that they recommend you to integrate with, and obviously it cannot be done with 1 to 2% of labor. But not only that, if you look at trainings are important. There are the baseline trainings, the baseline IT security trainings, or the baseline awareness trainings. But then you have the technology-specific trainings that you want to provide to your engineering teams. Because you want that a .NET developer will securely develop in .NET. And you want that a Java developer will securely develop in Java. And the practices are different. So how do you do that? The best practice? Provide the trainings. The practice is that it takes a long time to do that. So our trainings program actually took close to a year for our R&D organization. So think about the mapping that you need to do, identifying not only the roles within the engineering organization, meaning who is a developer, who is an architect, who is a program manager. You also need to identify the technologies that each individual works with. So that's a really big challenge. And lastly is risk management. How many of you heard about risk management or risk management programs? Great, so you're aware of that. You know that risk management is important. But in engineering, it's not a configuration thing, it's not a patch. In engineering, you actually need to develop code to make the change. So sometimes you cannot just fix stuff immediately. Sometimes you need to put the improvement cycles or the mitigations into the backlog. And when you put stuff into the backlog and you stack it up, eventually things will not get fixed within a day. Sometimes not even in 30 days, sometimes not even in 6 months. Not because security is not important, but just because sometimes redesigning takes time. And then you have your risk management program, and then you need to make someone to accept the risk. Oh, this is so tough. The people who accept those risks, they're usually executives. Try to figure out how to convince an executive to sign on something that can get him fired. That's nearly impossible. And then in the construction domain, there are also things that are kind of best practices, but very difficult to follow. So, documenting your threats, doing threat modeling, it's a best practice. But doing threat modeling in agile development environment, well, maybe for one product that's okay, but for 100, nearly impossible. Again, it's good to say so many things impossible. So what is possible? I don't know. No tips for today. So for the security requirements, an important question is, do you think that the security architect should be involved in every security, or actually in every requirement that is being introduced? Being involved in all of the architectural meetings is also nearly impossible, because you may have like 5 architects for a product, and you have 1 security architect. So he needs to find his way to work with those architects, and it's also nearly impossible. And eventually, the last thing is that even if you want to provide your best practices, it's also nearly impossible. Because there are best practices for web, there are best practices for native apps. What about mobile apps? Oh, wait a second, what about public-facing versus internal-facing products? Is it different? So it's also something that is very difficult to manage. And then in the verification phase, which is the third of the 4, you also have best practices. The best practice is to have design reviews. How many of you tried to reach out to an engineering team and get a design diagram for them? Okay, from the 5 that actually, raised their hand, raise your hand if it was extremely easy to get that. None. Okay. Yes. So, engineering people usually, they're smart people. They want to get things done. In many cases, they don't have time for documentation, and they won't give you the documentation. In case they can give you the documentation, you always need to remember that there's a difference between IT diagram and software diagram. IT diagram may have a firewall, may have a server, and may have some sort of sequence diagram. In software architecture, you will see classes, you will see interfaces, you will see all of those connections, and maybe even the database structure. So, it's not that easy to go through that if you don't understand how the application works. In the code review phase, it's very difficult to integrate yourself into all products because you may have different tracking systems, you may have different code repositories, and putting yourself in the middle is difficult if you don't have the baseline. If you do have that, that may be easier. And lastly, security testing. One of the measurements is, are you doing vulnerability assessment? Are you doing penetration testing? Many times, engineering teams think that when you scan them, you actually run penetration testing against them. If I'm running any desk scanner, I'm not penetration testing. I'm automating stuff to make it easier finding vulnerabilities, but it doesn't mean that we found the vulnerabilities that we're looking for. So manual penetration testing is expensive, but that's what should be done. And lastly, in the deployment phase, you probably heard a lot about shadow IT. Well, it's pretty common today in IT security. But in fact, in application security, you may have a shadow incident response team. The reason for that is because the application security folks, they usually somehow connected to the right networks. They can get responsible disclosure. Sometimes it can be actually a result of a shadow IT. And keep in mind that DevOps not usually include IT, they include Ops. And Ops can be reporting, are they to IT, are they to engineering, and that may be difficult. In addition to that, if you have an on-prem product and you try to provide the guidelines on how to harden the product, it may be configurations, it can be operating system hardening. So you have your baseline, you need to provide that to the QA team because they need to test your hardening. And eventually, let's say that they tested everything and now you deploy to production. The moment you have a problem, they will reach out back to you. So if there's a production, someday they will just point at you because you provided hardening. I'm not saying it shouldn't be done, I'm just saying it should be done very carefully. So including all of those practices, there are ways to measure that. There is no 100%. So if we look at a perspective for one of 100 products, you can actually build something like that. It's a spider chart. And you can actually see how well you're doing with all of those domains that I just mentioned. It will never be a full spider. But then you want to get more metrics. So one of the metrics that you can get is through the bug tracking system. So this is an example of a metric that shows the number of bugs reported versus the amount of bugs that were closed. A bug may be a security vulnerability. I'm talking only about security vulnerabilities. And then you may want to get more information. Maybe you want to get, the statistics of how many products are pending development or how many of them are in QA, because there is no black and white. You need to know what's going on in the engineering organization. You may also want to know what is the average time to fix a bug. Let me give you an example why you need this. If you're considering a bug bounty program, and in a bug bounty program you want to fix a vulnerability that just got reported within a specific time, you want to be quick, you can get all of those metrics from your bug tracking system. This is data. It's not what engineering organization can commit to. This is how they work, how they perform. So all of those are just, one of 100. This is something that is very difficult to manage per product. So how do you look at 100? So there are ways to look at 100 products. One of them is a very, let's say, highly sanitized chart that I have here. And this requires a little bit more consolidation, some sort of a BI tool that can actually give you all of this data from all of the tools that you have. It can be, TFS, it can be Jira, whatever works for you. You can actually consolidate everything and get the amount of bugs you have overall the company, or in fact overall the R&D organization. And then you can split it. You can say, interested to know what are the internal vulnerabilities that we discovered and what are the external vulnerabilities, because external vulnerabilities may be subject to the SLAs that we may have with customers. So this is quite important. In addition to that, you want to see that the chart isn't growing too much, because you want to see that the engineering organization is still able to follow your plan. You report on bugs, they fix bugs. But if you want to break it down for those 100 products, you can actually have a chart that actually includes the top vulnerable products. And if you have this chart, you can actually go to the executive teams and tell the specific executive teams, hey, your product is vulnerable, fix that. Or sorry, accept the risk. Accept the risk. So eventually, as I mentioned, there are best practices and there's things that we're trying to align. So let me explain you how we constructed our application security team within NCR. So we have 4 specialties in our team. The first specialty is an application security architect. This is a person who is involved in all of the security requirements, in the design reviews, in the code reviews. He's triaging the code defects that we have. Then we have an application security engineer, which is a more sophisticated role than a penetration tester. Because a penetration tester or a researcher, he finds bugs, period. The way that we're working out and improving this role is that the application security engineers are integrated into the development lifecycle. They not only submit their bugs, if they can develop a script and ship it to our QA teams, then the QA can do the test. They don't need the application security engineer to do that for them every time. And that's the purpose. Scale the capability of an engineer. If he does something, if he found a finding, let's make sure that this finding will not be repeated after all. Next thing is an application security program manager. This is a person who manages the overall program for the application security, meaning the person who makes sure that the architects are integrated into the development lifecycle, makes sure that the engineers get all of the environments that they need to do the pen testing. He actually the guy that generates the charts that you saw here. Means that I'm doing nothing. Yes. No, but basically this is the person that tracks the program and makes sure that we're going to the right direction. And lastly, the application security risk and compliance manager. is a person who assists us to track the application inventory, make sure that we have all of our risks managed. Or if we have risks unmanaged, he reports on that, and eventually it is being escalated. So when we built those roles, we actually broke it down to the OpenSAM standard, and we said, okay, those roles have specific requirements or specific capabilities that they need to have, and this is how we broke it down. I won't go through that, it's just a waste of time. So, when we prioritize security, we need to understand how much money each product needs to invest. And it took us some time to understand how to prioritize security correctly within R&D. So, you can look at regulated products, you can look at internal facing or hosted applications. Can be regulated or not regulated, and based on that, you can have a ballpark of where you need to invest in. Meaning, if it's an internet-facing application and it's regulated, it's probably have a higher priority over an just internet-facing application. In addition to that, you just need to align with the strategy of the company. And lastly, you need to understand the financial impact if a product gets breached. So this is a very nice theory, right? Hey, you need to prioritize according to whatever important to the company, which isn't a rocket science, and I suppose that it's nothing new that I'm telling you right now. What is new is how you calculate the labor for these priorities. So I built a calculator that eventually is being sent to the engineering VPs, and that tells them how many security people they need. So on the left side, you see the product type. It can be internet-facing or internet-facing and regulated, etc., as I mentioned. And then you need to say, okay, what is the percentage of R&D that I want of the AppSec for all of those types of applications? These numbers can be, you can change those numbers, just an example of how much should be invested. But it's pretty close to a reality of what should be invested. And then you calculate the total R&D labor, and eventually you calculate the labor that you need from the application security team, meaning how much time do you need from a program manager, how much time you need from a risk and compliance, architecture, and engineering. So, this is just an example. If you're, internet-facing and regulated product, then and you have about 1,000 employees in the R&D team, let's call it team, then you should probably have about 20 AppSec architects or AppSec team members, which is quite a lot for an internet-facing application. So, with all of that said, let's say that someone told you, we have a really big organization, just go and hire. Oh, we have such a shortage in talent that it's just impossible to hire people just like that. So it is a bottleneck. So what you can do to scale up your team is to build a satellite program. So a satellite program is a program where you scale up your team capabilities not only by your labor, but also by other people who are motivated to do security. And one of the examples for a satellite program is something like that. I don't know how many of you are familiar with the Six Sigma, but the idea is to give some sort of belts to people who want to get educated or want to do security for the company. So you have on the left capabilities, or let's say requirements, what each person will do, and then you have the belts. And a good example of someone who has a black belt is someone who wants to do security so much for the company that we need to reward him in some way. So someone who is a black belt will probably see himself a black hat. This is just an example, and obviously you can build your own. So how do you measure the effectiveness of what you're doing? First of all, if people shouting at you and saying, hey, I need more security resources, you're good. This is best way just to measure that. But except that you provide status reports to the management, you want to show them what's going on with the product. If you're having everything green in your chart, meaning everything is on schedule, that means that you're probably overstaffed. So just figure out the balance when you present that. Things that you can do year over year, you can make sure the overall maturity rank increases. You want to make sure that the amount of security bugs you have per X, whatever your X amounts of lines of code, is decreased, right? Engineering teams always will make some mistakes in security. People get on board, people take off, someone will make mistakes. So that's fine, you just need to make sure that you're in the right trend. And you always can get third-party companies to assess it for you. One of the things that we do to scale up the AppSec is actually having a 10 yes/no questionnaire that says, do you need a security architect or not? Things can be if data is classified, if it's regulated, if they follow some standards, if it's a customer-facing thing. You can build your own stuff. It's just an example of how you build it. And then you need to decide how to manage it. It can be on a file that you share on your bug tracking system that anyone can fill and eventually file, or you can do it with a collaboration page like, a Confluence type collaboration, or you can even build a workflow that eventually sends you notifications about requirements or involvement requirements. So scaling up security is difficult not only in the process, but also in the culture and the development lifecycle of the engineering. DevOps is it's a hype. Obviously, a bunch of engineering teams want to be part of the DevOps teams or part of the DevOps practices. You need to consider what continuous delivery does, what CI does, and maybe even agile development or waterfall development. You need to find yourself in all places eventually. I would start with hooking up into the DevOps part because everyone, well, not everyone, but at least many engineering organizations want to be there. So one of the things that you can do you can integrate with a release automation tool and build your own blocks with the release automation. You can do static code analysis. You can do interactive application testing. You can sign up binaries during the build process. Do obfuscation, whatever you need in this process. And then you build another block for staging, and then you build another block for production. And eventually you have your own blocks in security during the release automation process. This is how you scale AppSec with automation. But yet, sometimes you have important products that you cannot just scale yourself with the release automation process. So you need to find your quick wins. Sometimes you can say, okay, I'll just go and assign the software and that's going to be a quick win for me because it's not that expensive and I can do it like this. And eventually, when you have all of those quick wins, you also need to consider additional partnerships that can assist you scaling up. For instance, customer needs. Sometimes, let's say, small customers of ours, they have small IT shops and they want some managed security services, so we can provide that. I'm not marketing that, so don't think about it. I'm talking AppSec. There are some industry trends that we can be involved in, like, secure enclave corporations, or we can follow regulations like GDPR, and we can find quick wins from there. And also real security stuff, like, customers who may have breaches or suspect of having a breach, and we can talk with them to understand what their concern is in order to apply on our products. So, my quick tips is obviously security for AppSec, or at least 100 products, isn't easy. Try with investing like 80% of your resources in about 20% of your products. It's like standard 80-20. Reflect your success when you're doing this. You can, show the trending charts. You can talk with Black Hat, I think, maybe. But eventually, the things that you need to know going forward is few things. So let's say you want to do AppSec next week. You should at least be able to build a questionnaire with 10 yes/no questions. You should be able to identify your quick wins. In about 3 months, you should be able to build your own strategy based on company strategy, on the different product types, the development lifecycle types, and in about 6 months, maybe, if you're lucky, you can map all of your products and start executing your strategy. So that's my lesson. If you have any questions, I don't know how much time do we have? 2 minutes. Oh, sorry about that. So we can go to Reef A after those 2 minutes. Meanwhile, if you want to have any questions, you can go to the mics there. Just go to the mics and figure this out.
Yes, hello.
Yeah, I'm with you.
I work for a bank who is an NCR customer, and we had a very large ATM skimming incident recently, and I was wondering if you could speak to that and how it relates to secure software development.
So this is something, if you want to, we can talk about it offline, because it's a customer related. Okay? Any other questions? All right. Thank you very much.